Now you can fine-tune your reasoning models with 80% less cost and even up to 90% less token needed in your fine-tuning training data with a new fine-tuning approach called Unsupervised Prefix Fine-Tuning. Then, let's go. Right, let's get into sort of a new proposed approach on fine-tuning for reasoning models, which is based on a paper. It got published almost 2 weeks ago since the time I'm recording this video, so it's pretty new. And the approach that they're taking is very simple, but at the same time, it is very effective and also impactful in aspect of how much you pay for cost of fine-tuning a model and also accuracy of the fine-tuned model. So long as they're short, if you check out this paper at the beginning before I jump into my own visualization that can explain all this paper process, if you're gonna go with sort of now common fine-tuning approach for reasoning, one very common way is rejection sampling fine-tuning. So technically what you do, if let's say you have a specific use cases that you need to fine-tune a specific reasoning model, you come up with a sample questions, give it to the model to start fine-tuning. Let's say here's your question, and when you run this question to non-tuned model, you get maybe right or wrong answer. So you need to potentially by yourself go through all the generated samples for this question and choose the one that is correct and use that one for fine-tuning the model. So it can be used for distillation. That means you do it for a larger model to fine-tune a smaller model. But this is sort of supervised, and also you need to put all the answer inside sample data set for fine-tuning the model. But what they are saying is that in this paper is that no, you don't need to have supervised, you don't need to even have labeled answers here, and you don't need to have even full answer to fine-tune a model. In this proposed approach in this paper, they're saying that when you have the question for the answer, just provide the beginning of the answer. Let's say here with just 8 token or 10 token, because it has been proven that usually if the beginning of the answer is correct, the rest will follow the correct way. But if this part is wrong, the rest should be potentially even wrong as well. So technically, we just utilizing this part in your sample data set for fine-tuning, you can get even better results. Like they're showing that with this, I think they tried that with DeepSeek R1, Distill QN, and they have used, I think, Llama as well. And as you can see, compared to the baseline, they increase the accuracy, and also they reduce the token amount with 74 or even up to 81%. So I just provided a very quick and high-level explanation. Now let's dig into the main part. So this approach is called Unsupervised Prefix Fine-Tuning. Why prefix? Prefix means that beginning of the answer that I talked about, which is usually 8 or 10 or 16 token. So let's call it UPFT for now. So with UPFT, if we're gonna go with just custom approach, again, you might go with multiple samples that I just showed you. You need to choose the correct one, and you need to potentially have the full reasoning answer that is also higher token. But now what we're gonna do, we just use one sample per problem, one sample answer that I showed you, and just the beginning of that answer, 8 or something between until 128. Based on the type of the model you're fine-tuning, that number can be different. And up to this range, there's a reduction amount of compute and the token amount needed, and also increased accuracy. So it not only match the accuracy of traditional approach, but also even exceeds that, which is very, very impressive. Now, here's as an example. Let's say here, what you're gonna do, you have this sample for fine-tuning a model. This is your question. Again, as I showed you in the paper, the same thing. Just want to reiterate again, with traditional approach, all the answer has been given as a fine-tuned sample. But here, I'm just doing that for the beginning, so now you can see the amount of token reduced. For this example, let's say around 50%. Or another example, let's say you want to fine-tune a model that is good for math or some specific reasoning, and you want to say, find the sum of all positive integers in this equation. You see, if you're going to go with traditional fine-tuning, this is the full correct reasoning answer. But here, I just go with just the beginning, which we call it prefix solution. Now, one thing they found very interesting in the paper, and that's why this approach is working, is that they realize when they do fine-tuning with just a prefix, it seems like when you generate, let's say, around the first 8 token of the answer, usually the answers are at this stage mostly are the same regardless of if the model is correct or incorrect. But if we let model generate more than 8 tokens, now we see two paths. After 8 token, if the beginning is correct, the model go to the correct path, this purple. But if the model at the beginning is wrong, now after token 8, it will start also going to the wrong path. So seems like around 8 or 16-ish is the place that the model tend to go to the wrong trajectory or right trajectory. It's like human. If I ask you a question and I start asking you to provide your reason, if from the beginning I'm wrong with understanding what you mean or understanding myself, then I will start generating my next words that I talk to you right now in the wrong way. But if we fix that at the beginning, the chance of having wrong answer is less because I grasp everything and I can generate the next tokens properly in the right trajectory. That's why that prefix idea works. And again, based on the model, that 8 or 16 might be different. These are just samples, but in general, you can see how much you can reduce the token needed for fine-tuning. Here's an example of the accuracy when they did this with Llama, Cuban, and DeepSeek R1. The purple one is the baseline, and SFT is just regular supervised fine-tuning. But with using this unsupervised prefix fine-tuning, all the time, you can see the accuracy on the orange color is more compared to the rest. So how it works? What you need to do at the beginning, you need to first generate a single prefix for any question, only the first few tokens. How much? Depends on the model. For Llama, they realize that 8 token is pretty good. For Cuban, 32 token. For DeepSeek R1, 128. It is because these models has been trained differently. If let's say this one is trained well on math challenges, then maybe just with some initial tokens, smaller samples, they're good to find their correct trajectory. And that's why maybe it's a shortcoming of this paper, or that's a hyperparameter tuning that you need to figure out what is the minimum token needed for going forward and fine-tuning your model. And then you just need to do that for your small percentage of data and start fine-tuning. And for the inferencing, you don't need anything fancy or specific. Just go with as is, like regular fine-tuning. Okay, so what they did, they actually did this prefix sort of unsupervised fine-tuning with these models, and they distilled these models with a larger model. And the prompt that they used was, here's a question, give me just the initial steps. From this answer, they got that initial prefix and they ignored the rest of the answer. So maybe this is something you can take it for creating your fine-tuning data for this specific version. And in general, what this approach is trying to do is finding the right prefix that is small enough but cover well and also provide the highest accuracy. This is the balance we need to find, because yes, if our prefix coverage is larger, much more tokens, then yeah, our reasoning answers are more accurate, so potentially we got to the better accuracy there. But we're gonna actually try to see if with lower amount of tokens we provide a good coverage and high accuracy. And for implementation, they actually did this with this data set, and they benchmarked that in their paper, that with this data they proved that the approach is working better compared to traditional fine-tuning. And this is some hyperparametering that they use for all the models, and they fixed it to have an apple-to-apple comparison. And lastly, just want to show you some key takeaways. With this approach, they highlighted that the fine-tuning time got reduced, the sampling cost got reduced, and performance gain on average was 4% even more, or matching previous ways of doing fine-tuning. And in general, if you ask that how come this approach is working, just reiterate that again, why this UPFT works. It's because all the fact that among all the right and wrong answers of reasoning models, sort of initial stages are the pivoting moment. The initial part of the answer is really effective on the rest of the answer. That's why that prefix is really impactful to be used for fine-tuning this model. And again, in general, it's used also without any labeled data, so you don't need to worry about creating reasoning answers, finding the right one, and labeling that as needed. To help you understand this better, I actually created a couple of sample examples with data sets to show you how you can do fine-tuning with this approach. Let's say you have a business use case and you want to create a reasoning assistant that helps with some financial problems like investment, so on and so forth. And it's like a chatbot that you need to give access to your customers. So let's say if a customer asks what will be a compound interest on this investment, blah, blah, blah. Now, if I'm gonna go with prefix fine-tuning, I don't need to provide the whole answer as a fine-tuning sample data. Just the initial 26 token count here up to here is good enough for me, and I don't care about having a label data running that again against a larger model to check if it's gonna work or not. So I'm gonna do the same thing for all the answers, and hypothetically this is the amount of improvement that you can gain. Another example here that we can go forward, and by the way, this is the same template I showed you in the prompt, the paper they use. Now it is adjusted for this financial question. Some other more examples. This is just a financial service. Let's say for customer support, you want to have a chatbot that can automate troubleshooting. So you want to make sure that your chatbot is expert enough for reasoning that are aligned with your domain, with your customer support application. So maybe just off-the-shelf model are not good enough for your reasoning task. So fine-tuning and going with this approach is a good choice. Same thing for inventory optimization or healthcare if you want to have some clinical decision support for healthcare providers, or legal document analysis that they need complex logical reasoning. You might need to do some fine-tuning. So again, to just wrap up step by step what you need to do, grab some sample data set, generate just the beginning of the prefix of the reasoning answer, fine-tune the model, go ahead, reiterate that fine-tuning until you come up with the metrics that you satisfy your evaluation results, and move on with your approach. Some common pitfalls I would say from this solution is that maybe your prefix is too short if you are not getting your optimal outcome. So maybe grab a larger portion of the beginning of the answer. And this is not something relevant to this approach. Overfitting in general is a shortcoming. In case you want to get trapped in, make sure you go back and reassess the data set you use for fine-tuning. And of course, evaluation metrics is needed, what you need to choose based on your business and technical requirements, and diversity. Don't just oversample a specific area of your reasoning. Try to have a comprehensive one. And here are also some heads up that how you can overcome these common pitfalls that I just walked through them. Alright, that was quickly an overview of this Nissan approach, and I found that pretty actually creative and at the same time impactful. So I will add the link of this paper to the Discord channel, and the link is that under video description below. Check it out if you're interested to go through the details, and I hope you enjoy this video. That's all.
These sentences will transform your life, so repeat them every day. That I'm calm, I'm focused, I'm clear with my decisions, I know my next move, I'm not distracted, I built my life foundation based on personal discipline and respect. And lastly, God is on my side. Dream big, my friends, believe in yourself, and take action. Till next video, take care.